Today, we're solving a system of equations, but not in the way you might expect. We'll compare two methods, the traditional substitution approach and a much faster technique that uses pattern recognition. Same problem, very different journeys. Here's our system. X plus y equals 6 and x times y equals 36. Most students see this and immediately think, I'll use substitution. And that works, but there's something special about this setup that we'll discover in a moment. Let's walk through substitution first. We solve the first equation for y, getting y equals 6 minus x. Then we substitute that into the second equation. X times the quantity 6 minus x equals 36. Expanding this out, we get x squared minus 6x plus 36 equals 0. Now we need the quadratic formula. The discriminant is 36 minus 144, which is negative 108. Plugging into the formula, we get 6 plus or minus 6 times the square root of 3i all over 2. This simplifies to 3 plus or minus 3 root 3i. It works, but it's a lot of computation. But wait, look at what we're given. We have the sum of two numbers and the product of two numbers. Does this remind you of anything? When we factor quadratics, we use the exact same pieces, the sum of roots and the product of roots. This means x and y are actually the two roots of a quadratic equation. Here's the shortcut. If we know the sum and product of two numbers, we can write down a quadratic equation that has those numbers as roots. The form is t squared minus the sum times t plus the product equals 0. So we write t squared minus 6t plus 36 equals 0. Now, instead of using the quadratic formula, let's complete the square. We add and subtract 9. T squared minus 6t plus 9 is a perfect square. That's t minus 3 squared. And we're left with plus 27 on the other side, which we move over to get t minus 3 squared equals negative 27. Taking the square root of both sides, we get t minus 3 equals plus or minus 3 root 3i. So t equals 3 plus or minus 3 root 3i. Same answer as before, but with far less work. Either way, we get two solutions. X can be 3 plus 3 root 3i, and then y is 3 minus 3 root 3i. Or we can swap them. Both pairs satisfy the original system. Let's compare. Substitution took 4 major steps with lots of algebra and chances for mistakes. The SMART method took just 2 steps, way less calculation, and gave us insight into the structure of the problem. Both get the same answer, but one is clearly more elegant. Here's the takeaway. Whenever you're given the sum and product of two unknown values, don't immediately jump to substitution. Recognize the pattern. Those two pieces let you build a quadratic equation directly. Use t squared minus st plus p equals 0, where s is the sum and p is the product. This is a perfect example of why pattern recognition is so powerful in mathematics. Before you dive into calculations, step back and look at the structure of the problem. Often, there's a smarter path hiding in plain sight. Train yourself to see these patterns, and you'll solve problems faster and with more confidence.